Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject short range wireless communication. We're going to see a new technology, that is UROOF technology, in this particular video. You will see about what is UROOF technology, what is the basic concept behind it, what is the advantage and benefits of it, what are the different components that is used in UROOF technology. So to start with, I'll tell you what is UROOF technology. UROOF, that is UWB radio over optical fiber. That is UROOF technology. UWB radio over optical fiber. That is pronounced as UROOF technology. First, we'll see what is UROOF technology, right? So, when we say UWB radio over optical fiber, you can understand that UROOF is nothing but it is a combination of two different technology. That is UWB and ROF. ROF is nothing but radio over fiber. That is, we're going to transmit radio signal over optical fiber. That is ROF. And we already seen what is UWB technology in previous videos. UWB is the very powerful technology in short range wireless communication. So we have a lot of benefits in UWB, and also we have more benefits in ROF technology. So by combining UWB and ROF, what we're going to achieve is we're going to achieve both the benefits of UWB and as well as ROF technology, right? So this is the just introduction about UROOF, and we will see in depth about this particular technology. And as I said, what we're going to do right now is we're going to extend the UWB transmission capability using ROF technology. To make it very clear, just understand this, we're going to combine UWB and as well as ROF technology. That is, say for example, you have UWB transmitter, and then you have UWB receiver. So you have UWB transmitter and UWB receiver, right? But we're going to combine UWB and as well as ROF technology. Why we are going to combine? I'll tell you that. We know that UWB has a lot of advantages. That is, it has wide bandwidth. That is, it covers from 3.1 to 10.6 gigahertz. When we say it has a wide bandwidth, the data rate is very high, and also it has a huge capacity. It has penetration capability. It has high resolution, so that it is used in radar and military applications. You have lots and lots of applications, advantages in UWB. And even in your mobile phones, that is in Apple mobiles, right now we have UWB integrated antennas over there, UWB chip integrated, right? AirTags works with UWB technology. So you have a lot of advantages, and the only limitation in UWB is the range of UWB. When we say the range, the transmission range of UWB will be up to 10 meters, maybe up to 20 meters, but max, like theoretically we can say it is 10 meters. It covers only up to 10 meters. That is the greatest drawback. We have a lot of advantages. That is, it is a powerful technology in short range communication, but the range is very limited. And if we're going to extend this UWB to a larger distance, that is, say for example 1000 meters, right, we can able to achieve the benefits of UWB technology, that is all these advantages, and similarly we can able to overcome the drawback of UWB, the limitation, the range can be extended, right? And that too by using ROF, that is, we're going to transmit over optical fiber, right? So if you're going to transmit over optical fiber, we will acquire all the advantages of optical communication as well. That is, when we transmit using optical fiber, that is, the ROF technology has a lot of advantages like lesser noise, right, higher data rate, and high bandwidth. All these advantages can be combined, and that is why we go for this UROOF technology. right? And coming to this explanation, as I said right now, as I said, UWB, UROOF technology, what is that we're going to do? We're going to extend the range of UWB using RF technology, right? So which means you'll have UWB transmitter which transmits the UWB signal, and this UWB signal is converted to an optical signal before it is received by the UWB receiver. This UWB signal, the UWB signal is an RF signal, that is radio signal, right? So at the transmitting side, when it is transmitted, it will be converted to the optical signal and it will be transmitted in the optical fiber, and before it is received by the receiver, once again the optical signal is converted to RF, and then it is received by the UWB receiver as an RF signal. And so the transmission and the reception is going to happen only with the UWB signal, that is RF signal, but the transmission inside the optical fiber is going to be happen with optical signal, right? So which means what we are going to do is we are going to superimpose the UWB signal with the optical carrier and we are going to transmit it, so that we can able to achieve all the advantages which I said. And when we say this UROOF technology, we know that right now we need UWB transmitter, UWB receiver, and we need components to convert RF to optical and optical to RF, right? So these are the very fundamental components that is needed for UROOF technology. We will see about the components, technologies in further videos. Today in this video we will see about the advantages, the introductions about UROOF technology, right? And the main reason of this UROOF technology is it is mainly focused on wireless personal area network. As I said, we're going to extend the UWB range to a greater range so that we can achieve all the benefits of UWB in a wider range, right? And whatever I said, that is what given here. So you can see the main idea of UWB radio signal, that is to deliver the UWB radio signal over mixed wireless RF and optical channels, where the optical parts serve as a super efficient transmit medium. This concept is called as UROOF technology. And we know that we need electrical to optical conversion and optical to electrical conversion in UROOF technology. And these are the many important service and applications. The range extension of wireless personal area networks up to 2 to 3 orders of magnitude can be achieved using UROOF technology. And similarly, new optical wireless infrastructure capable of delivering broadband multimedia above 1000 Mbps per traffic, that is achievable in remote areas. And also another important application is homeland security, where we will acquire data from various sensors which is capable of using UWB technology, and the same can be transmitted over optical fiber through a longer range using UROOF technologies, right? These is benefits of UROOF technology. And we already know the features of UWB technologies. I have said UWB technology is faster emerging technology, and it is world vision 4G systems. It has a great impact in world vision 4G systems, and it is a very powerful technology in short range communication. And as I said, in indoor communication, we have already posted a lot of videos about UWB, the applications, features, everything about it. And you can see the range is 3.1 to 10.6, and very recently it is extended, that is 57 to 64 gigahertz can also be used for UWB. And the ultimate aim of UWB systems is to utilize broadband unlicensed spectrum, right? And the other potentials are, the other advantages are low complexity, low power consumption, and the main important feature is it has a wide bandwidth, and so it can be used in localization and tracking features, where, as I said, Apple AirTag uses a UWB chip for its application. Based upon UWB technology only, Apple AirTag works, right? Even in your Apple mobile phones, you have UWB chip integrated, right? So with this, with this particular features, it can also be used for accurate tracking, location safety, and homeland security, right? And that is why it is a very powerful technology in 4G systems and also for short range communication. But when it comes to limitations, as I said, the UWB applications, you have a lot of variety of applications in UWB, but the limited range, that is the greatest drawback of UWB. That is, it is less than 10 meters, right? And also it has limitations with capacity and as well as the emission level. Whereas right now, if you want to extend from 10 meter to 1000 meter, that is possible with the broadband access technology. That is possible. That is why we go for UROOF, where we can able to extend the range of UWB to a greater extent, right? And this new concept combining UWB and as well as ROF, right, gives you a lot of advantages of both UWB and as well as the optical, right? And the main idea behind the proposed concept is to enable transmission of UWB radio signals over optical channels. I've said that. And this concept is called as UWB radio over optical fiber, which is UROOF technologies, right? We will see about the advantages of this technology, where as I said before, UROOF combines the RF signal and as well as the optical signal. We're going to superimpose the UWB signal with the optical signal so that we can able to transmit to a very longer distance. And we have a lot of advantages. That is, it makes conversion process transparent to the UWB modulation method and also avoids high cost of additional electronic components required for synchronization and other process. It makes possible integration of all RF and optical transmitter components on a single chip, right? And the overall combination of these features results in cost-effective broadband system that can easily support 1 Gbps per second, which is suitable for residential market and as well as UWB, WPAN, right? As I said, this is mainly focused on wireless personal area networks so that we can able to extend that particular range and we can able to achieve a cost-effective broadband system, right? So this is the greatest advantage about this particular technology. We will see more videos about this particular technology, how it works, what is the modulation methods, what are the different components that is used, how we convert UWB signal to optical and optical to UWB. All are very interesting concepts. We will see all these videos in future, right? So today what we have seen is we have seen what is UROOF technology. We have seen the advantages, disadvantages of UROOF technologies. We have also seen what is the limitations of UWB, why we go for UROOF, right? I believe this video will be very useful for you. Thank you, my dear students.